no! I've dropped some nails into the beaker. Teacher, how should I take out the iron nails without staining my hands?
Try using a magnet.
A magnet?
Do you know why?
A magnet is able to attract magnetic materials. These iron nails are magnetic. I know! We can make use of magnetism to draw out the iron nails from the beaker.
That's right. Magnets can exert forces on objects made of magnetic materials. These forces are known as magnetic forces.
When magnet A attracts magnet B, does that also mean that magnetic forces are at work?
Absolutely. Can you recall the properties of magnets?
Unlike poles attract, while like poles repel.
Very good. Magnets are able to exert forces of attraction and repulsion. Look at the following example. What kind of force are the magnets exerting?
I know! They are exerting a force of attraction on each other.
What about the next example?
It is exerting a force of attraction as well, but this time on the paper clips.
And how about this example?
In this case, the magnets are exerting a force of repulsion on each other.
I am proud of you, Turbo Girl. Do you know what this is, Turbo Girl?
This is a spring.
What will happen if we stretch or compress a spring?
It will change its shape and length.
Very good. When the spring is being stretched or compressed, a force is actually acting on it. In this case, the pair of hands is exerting a force on the spring. In turn, the spring exerts a force on the hands.
What is this type of force called, teacher?
This is known as elastic spring force.
Does the spring change its shape and length after all this stretching as well as compressing?
No, it returns to its original shape and length.
Today, I've learned more about forces.
Do you still remember when a magnet is able to exert a force of attraction?
That's easy. A magnet can exert a force of attraction in two situations.
What kind of situations?
Firstly, between two unlike poles of magnets. Secondly, on magnetic materials.
What about the force of repulsion?
A magnet will exert a force of repulsion when two like poles face each other.
Great! What about springs? Which properties of the spring remain unchanged after being compressed or stretched?
Their length and shape. When compressed or stretched, a spring exerts an elastic spring force on the object stretching or compressing it as well.
Excellent! That's all for today. See you soon.
Bye, teacher.